Well, hello friends. In this video we will continue our examination of comparative analysis leading through the t-test, the ANOVA, and the MANOVA. This video we will examine t-test, look at the t-test to see what it actually does entail. The t-test is a comparison of one dependent variable across two groups. The dependent variable must be randomly selected, continuous, normally distributed, and possess homogeneity of variance between the two groups. Again, homogeneity of variance means that the variances are the same for the two dependent variable samples taken from the two different groups. Remember, when the t-test is an ANOVA with only two groups. Now, let's go back to this diagram just a minute. Here you have group 1 and group 2, and you have the dependent variable which has value 1 and value 1. Now, that's a t-test. Look at the difference in an ANOVA. ANOVA can have two or more groups. When an ANOVA has two groups, it is a t-test. When it has more than two groups, then it's referred to as an ANOVA. ANOVA has two or more groups and one variable, simply like the t-test does. Now, you will notice here that I put in normally distributed curves. I want to remind you that these variable values, this dependent value that we've selected here, should be normally distributed. T-test assumes that it is. Now, the research questions for a t-test are focused on differences. You remember that correlational studies were founded on relationships. Well, comparative studies are based on differences. For example, we'd start with a descriptive question. What are the percentages of female students in two-year degree-granting public and for-profit colleges in Texas in 2011? That's simply the descriptive, looking for the percentages of females in two different groups. You can see that the groups are public two-year colleges in Texas and for-profit two-year colleges in Texas for the 2011 year. Now, here is the methodology question. Does a difference exist in the percentages of female students between public and for-profit two-year degree-granting colleges in Texas in 2011? Now, we have a descriptive question, we have a methodology question, which is considered good format as you do a quantitative study. Here are the hypotheses. The hypotheses, remember, are not needed for question 1. They are needed for question 2, which is a methodology question. We would start with a null hypothesis that no difference exists in the percentage of female students between public and for-profit two-year degree-granting colleges in Texas in 2011. The alternate hypothesis would be that differences exist. So, you have a null hypothesis and you have an alternate hypothesis. Now we will take just a minute and go over and look at how we would conduct this study in SPSS, what we would do to do a t-test. Well, here we are, my friends, in SPSS, and I have developed a software or a data set. This piece of software is very powerful. Now, the variables that I developed are percent women and group. My group statistics is represented. One represents a public two-year degree-granting community college in Texas, and we'll scroll down, and group 2 represents a for-profit two-year degree-granting institution in Texas. Now, what we're going to do now is we're going to run a t-test. So in order to run a t-test, we will go up to Analyze, and we will start down the list. We have reports, descriptive statistics, tables, compare means. Now, if we compare means, what we're going to do is go to independent samples t-test. Would you agree that the percent of women in a public two-year degree-granting institution in Texas is probably independent of the percent of women in a for-profit two-year degree-granting institution in Texas? So we go to compare means and to the independent samples t-test. Now, what we've got to do is that I've already run it, just playing with it. Let's do percent of women will be our test variable. Our group will be our grouping variable. Now we will need to go in and define groups, group 1 and group 2. Now then our groups are defined. Let's go up to options. We want a confidence interval percentages and all of this. So let's get it done. I think we've got everything that we need there. Let's tell it to conduct the study. Now it will go out and it will conduct the analysis. That's what it's doing right now. First thing that it gives us are our group statistics. You'll notice that we had 63 public community colleges and only 52 for-profit two-year degree granting institutions. The mean percent of women for the public group was 58.25, 72.17 for the for-profit group. With standard deviations, we have those things that we need: the number, the mean, and the standard deviation for your table. Now, what we will do next is look at this independent samples test. And this variable was run. It's assuming equal variances. It had an F statistic of 29.109. It is highly significant. In other words, the null hypothesis is there is no difference. If the significance is less than 0.05, then we reject the null and we accept the alternate hypothesis that difference exists. So we're very certain that these two averages, the average percent of females in a public two-year degree granting institution and in a for-profit two-year degree granting institution in Texas, differ, and we can prove that statistically. Now, isn't that cool? Now, of course, the test assumes homogeneity of variances between these two samples, and if we don't assume equal variances or homogeneity of variance, we still have a significance of 0.000. I do want to point out to you that our significance really is not zero. There is no way statistically to come up with a probability of 0. Our significance is less than 0.001. That's the way that you say that. Well, guys, I hope you enjoyed that. Let's go on and see if we can conclude this exciting lecture. Well, my friends, wasn't that an exciting excursion into SPSS? We know that for 2011 now that the percentage of women enrolled in two-year public degree-granting colleges in Texas differs from the percentage of women enrolled in two-year degree-granting for-profit colleges in Texas. Isn't that cool? Again, I want to thank you very much for your support. Live long and prosper, peace and long life, and may the odds be ever in your favor.